All right, AI2, welcome back. Today we're going to talk about organizing data and a couple things you can do with data. The first vocab word I have for you guys is univariate. Univariate, that whole just like a unicycle has one wheel, univariate data has only one variable. That means like if you're collecting the heights of kangaroos in Australia, that those are just like one number. It's not like the height and weight. That would be like bivariate data because there would be two things per kangaroo. Qualitative data has that word quality right inside of it. So qualitative describes the quality of the data. So just a couple examples here. I already took the well, I'm going to do an example for qualitative, sorry. Qualitative is something that's non-numerical. So, for example, the brand of toothpaste that you use. So if you were to collect all this data from your friends, like what kind of toothpaste you use, they would be like, Crest, Johnson & Johnson. Like they wouldn't be numbers, they would just be names of things. Now, quantitative data has that word quantity inside of it, which means that it has to do with numbers, numerical. When you're gathering quantitative data, there's usually two different kinds. There's discrete and continuous. Discrete are kind of like these hard, finite numbers, and they're usually the result of counting. So, for example, the number of pets you have. So in that case, you wouldn't have to measure anything. It would just be like counting on your fingers. I have 4 pets. It wouldn't be like 4.5 or something like that. Continuous data is usually the result of measuring. So that's a measuring of any kind. That's like weight, time, volume. So we'll say like the miles from your house to your school. I realize that you might count those up on your fingers and be like, oh, it's 3 miles or 4 miles, but it could be like 3.2 miles or 3.1, or it could be like, really uncomfortable numbers that are the result of measuring. A big way to organize data is with something called frequency tables. So frequency tables just tell you how often a certain kind of data point is occurring in a data set. So let's go back to that example earlier of how many pets a student has. Let's say I asked a whole class how many pets they have, and this was their answers. These were their answers. The first kid had 3, then the next kid had 1. The first thing I notice about this is that it's not organized very well. It's not in numerical order. It doesn't go from least to greatest. It's kind of a mess to look at. Some other things I notice are that there's a lot of repeats. Like, a lot of people have 1 or 2 pets or no pets. So a better way to organize this would be with a frequency table. Here on the left, you will see all the different kinds of numbers that occur. There's 0s, 1s, 2s, 3s, 4s, a 7, and a 16. So all those need to be on that side. This side tells us how often those things occur. So if I go through and count up how many zeros there are 1, 2, 3, 4, 5, 6. So I put a 6 right here to tell me that there are 6 people that have 0 pets. Then 1 pet, there's 1, 2, 3, 4, 5, 6, 7, 8. So 8 people that have 1 pet. 2 pets, 1, 2, 3, 4, 5, 6, 7. 3 pets, 1, 2, 3. 3 threes. Now 4. 1. That's it. So we put a 1 there. And then I believe there's also just 1 7 and 1 16. So 1, excuse me. Oh, here we go. 1 and 1. If we counted all these up, this should tell us how many people are in the class. So let's see, 6 plus 8 is 14, plus 7 is 21, plus 3 is 24, 25, 26, 27. So total, 27 kids in class. Very small class size these days. Next up, this one's straight out of your book. It's one of the examples. It's the age of boys in a football club, but IB is a British curriculum, so they are probably talking about soccer, as we call it here stateside. First thing I noticed about this data, it's not organized. It just goes in random orders. The first question is whether or not it's continuous or discrete. So it's the age of boys in this football club. I realize a lot of people might think age is kind of counting on your fingers, but it is measured by time. You can be 13 and a half or 13.1 or something. So this is not discrete, continuous. Now, down in this table, they say construct a grouped frequency table. Grouped means that there's sort of intervals for each type of data. You're still counting up how many people fall into that. And this is kind of a silly one because it's like this interval right here means starting at 10, including 10, and going up to 11, but not including 11. So it'd be like 10, 10.1, 10.2, all the way up to 10.9999 repeating, but not 11. The next interval right here would be starting at 11, going up to 12, but not including 12. So really, it's kind of like we're looking at discrete data and we're just tallying up how many of each kind there are. So if you went through and checked those off, it would be like 7 people are 10, between 10 and 11. And then 9 people are 11, not quite 12. And then 7 people in the next. And then there's 3. And then 4 and 5 and 5. So this is a grouped frequency table because these are groups. If they ever give you a set of data and tell you just to group it however you like, in general, the rule of thumb for how many groups is like, 5 to 9 groups is usually good for looking at the data. But it's kind of up to you if they don't tell you what intervals to use. Now, way back when, you guys probably learned mean, median, and mode. Mean is the average of the data. Median is the exact middle of the data, and I'll show you guys how to find that. And then mode is the one that occurs the most. Mode most. That's like the easy one to remember. So let's say I had 14 students that took a test in a class, and these are their scores. Low of 35, high of 91, so a very wide range on this test. Find the mode, part A. The mode is going to be the one that occurs the most, so just looking at the data, there's not a ton of repeats, but I do see that 58 occurs 3 times, so that is going to be the mode. The median, is going to be the exact middle. So some people like this cross off from the sides method, so like cross these 2 off, and then cross the next 2 off, and then keep going like that until you find the exact middle number. But you'll notice I'm about to cross both of these off, so it's like the middle is actually both of these numbers, but it's not, I shouldn't say that, it's not both of those numbers, it's the average of those 2 numbers together. So the median is going to be 66.5. Now, to find the mean, you would take all of these scores and add them all together. So this would be like 37 plus 47 plus 49 plus ... all the way up to 91, and then we need to divide that by how many there are. Now, it told us that there are 14 students taking the test, so we're going to divide that by 14. If you crunch that out, crunch, 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 you get 66 is the average. Excuse me. Now, this last part is kind of interesting, and it seems to be a common test question with problems like this. A 15th student takes a test, also takes the test, and the new mean is 66.2. What is their score? Well, first thing we know is that the mean went up, so their score was better than 66. So, you guys, if you take all 15 students, so picture 15 scores. So it's like 15 scores all being added together, and then it's divided by 15, and this equals 66.2. Well, we know through algebra that you can multiply both sides by 15 to cross out the 15 on the left. So if I blast this with a 15 and also blast this with a 15, then these 15s go away, and then 15 times 66.2 is 993. So we know all the numbers added together equal 993. Now, our previous total, when we added all of this together right here, if you take just the 14 scores and add them together, is 924. So if we subtract out the 924, that'll tell us what the new test score is, which is 69. Which was bigger than 66. That's what I thought would happen. So, the last thing in your homework section is it says to use technology to find the mean, median, and mode of a frequency table. I'm going to show you guys how to do it by hand real quick, and then next class I'll show you guys how to bust it out using a graphing calculator. So, if you were to find the mean, median, and mode of this data right here, some people, if they were unsure how to do it, would list out the actual data. That it'd be like, there's 6 10s. So they'll go, 10, 10, 10, 10, and do 6 of them. And then they'll put 11 or 8 11s, and then 10 12s, and then 4 13s. But really, that's doing too much. It's so repetitive. So we are not going to take that method. We're not going to do that method. What do we know about this data? Well, I think the mode is the thing you can spot first. The mode is the score that occurs the most. Remember, all your scores are these up here. The entire data is nothing but 10s, 11s, 12s, and 13s. The one that occurs the most is right here. There are 10 12s, so that's definitely the mode. "12" is the mode. Now, the next thing I think we should tackle is the median. The median is the exact middle. To find the middle, I need to know a total frequency. So if I add all these numbers together, 6 plus 8 is 14, plus 10 is 24, plus 4 is 28. So there's 28 total pieces of data. Now, if you take 28 and split it directly in half, that means there would be 14 in the lower half and 14 in the upper half. So I need to figure out where the 14th piece of data is. Well, the first 6 are 10s. Then the next 8, so that's like 7th, 8th, 9th, 10th, 11th, 12th, like all the way up to the 14th are 11s. So that means that the 15th piece of data is a 10. So the first 14 are 10s and 11s, and then the next one is a 12, and then the upper half of that data is all 12s and 13s. So the median actually lands directly in between the 11 and the 12. So it's the average of the 14th and 15th piece of data, which is 11.5. Now, the quick way to find the mean. there's 6 tens, which means you could add 10 together 6 times, or if you're adding something multiple times, that's the same thing as multiplying. So we are actually going to take each number and multiply it by its frequency. So this will be 10 times 6, but then we got to add all the 11s, which there are 8 11s, and then there's 10 12s, and then there's 13 4s, or 4 13s, excuse me. That will be the grand total for everything. And we know there's a total of 28 pieces of data. Gosh, excuse me. That's when I'd reach for my TI calculator and do 10 times 6 plus 11 times 8 plus 12 times 10 plus 13 times 4. And this is a total of 300. So it's 300 over 28, which is about 10.71. My general rule of thumb is 2 decimal places when you're rounding. Rounded appropriately, of course. All right, you guys, your homework is 3A, 3B, and 3C. Good luck.